Imagine you are a lone astronaut drifting peacefully through the quiet beauty of deep space. Suddenly, your navigation panel lights up with a warning. You've drifted into the gravitational reach of one of the most mysterious objects in the universe, a black hole. Before it was a black hole, this was a massive star. When that star ran out of fuel, its own weight crushed it, forcing all of its material to rapidly collapse inward into a single, unbelievably dense point. That density creates a gravitational pull so extreme that it traps everything. Even light, the fastest thing in the universe, curves back inward. When light cannot outrun the gravity, nothing else can. Every black hole holds the history of a collapsed star within its center. To see how that concentrated mass behaves, we have to steer our ship closer and watch what happens at the very edge. You inch the ship forward, creeping toward the swirling shadows at the perimeter. You are approaching an invisible mathematical boundary in space called the event horizon. This line marks the exact distance where the speed required to escape the black hole becomes faster than the speed of light. Outside this dashed line, you can still fire your engines and fly away safely. But the moment even a single atom crosses that boundary, its path is locked. All possible directions in space now permanently point toward the dark center. Crossing this threshold changes your mission instantly. You are no longer observing from a distance. You have begun a one-way trip into extreme gravity. As your ship tumbles over the edge, you fall feet first into the void. Because you are falling, your feet are physically closer to the center of the black hole than your head is. That tiny difference in distance means the gravity yanking on your feet is vastly stronger than the gravity pulling on your head. Your lower body begins to accelerate much faster than your top half. The sheer difference in force stretches your body out like a piece of warm taffy. At the exact same time, the converging gravity pulls the sides of your body inward. You are being stretched vertically and squeezed aggressively from both sides. Astrophysicists have a technical term for this process of vertical stretching and horizontal compression: spaghettification. Gravity here does more than just pull you down. It actively dismantles the physical structure of your body, reshaping solid matter into a string of atoms. Let's step back and look at this from a safe distance. Imagine a friend is watching you fall from a ship stationed far outside the event horizon. The immense mass of the black hole warps the fabric of space, which also causes the actual flow of time to slow down. To your friend watching through a telescope, you wouldn't look like you were falling fast. They would see you moving in extreme slow motion. As you got closer to the edge, you would appear to slow down more and more, until you eventually looked completely frozen in place at the boundary. The black hole creates its own local reality, entirely isolating you in a pocket of warped time and space, completely separated from the rest of the universe. Deep inside, past the event horizon, you finally reach the absolute center, the singularity. Every single star, planet, or astronaut that falls in gets crushed into this infinitely tiny, endlessly dense spot. The environment is so extreme that our current mathematical formulas and laws of physics completely break down. We simply cannot calculate what happens here. The singularity marks the edge of current human understanding. It exists as a physical reality that our math simply cannot describe yet, an observation waiting for a more complete theory of gravity. If that sounds like a lot to handle, let's zoom way out to look at our own Milky Way galaxy. Right at the very center of our galaxy, there is a supermassive black hole that is actively churning away. It's called Sagittarius A star, and it has the mass of 4 million of our suns. But you are completely safe. Earth is located in the quiet outer suburbs of the galaxy, a massive 26,000 light-years away from that gravitational trap. There are wild, mind-bending phenomena out there in the cosmos. If exploring the unknown makes your brain light up, hit the subscribe button to join us for our next deep space adventure. The universe is filled with overwhelming forces, but our ability to study them safely through science turns that fear into wonder. See you out there!